Alright, so let's take a look at the second page of the test review. Number 15 says that we're going to find the major arc DPA. So, if we look at this problem, notice that the vertex is outside of the circle. So if the vertex is outside of the circle, we're going to be applying that formula where the angle is equal to the big arc minus the small arc all over 2. But here's a problem. We don't know how long this arc here is, and we don't know how long this arc is. So what am I supposed to do? This problem is actually challenging, and what I'm going to do instead is look at number 16 so I can have an idea on what to do for number 15, or demonstrate my point so that 15 makes sense. So let's take a look at number 16 together. Find the measure angle A. Here's angle A. Note that the vertex is outside of that circle. So we're going to be applying that formula. The angle is equal to the big arc minus the small arc all over 2. And here's the thing. We're dealing with two rays where they are actually the tangents of our problem, of our question. And since these are tangents, and this arc here is 99 degrees, then how long is this major arc? Well, know that a circle is 360 degrees. So I can do this. I can do 360 minus this arc, and that's going to give me 261. Okay, so that major arc here is 261 degrees, and this minor arc here in red is 99 degrees. 261 plus 99 is 360 degrees. I just found my major arc and my minor arc in terms of their measures. So, okay, so we have the vertex outside. So that means I can say the measure of angle A is equal to the big arc minus the small arc all over 2. So the measure of angle A is equal to 81 degrees. And that's your answer. So this question is very similar to this question. The vertex is outside, we're dealing with two tangents, but this one, we don't know the value of the major arc and this minor arc. The question here says, find measure arc DPA. Again, this is DPA. So that's basically saying, oh, let the major arc DPA be X. So this major arc here is going to be X. Well, what's left over? Well, we know that a circle is 360 degrees, and I have part of my 360 degrees. That's X, right? X is part of 360. So what's left over? Well, y'all, it's basically 360 minus X. So, okay, I have my X, and I have my 360 minus X, and there's my angle. So I'm going to apply that formula where the vertex is outside of the circle. That's number one, right? If the vertex is outside of the circle, then I'm going to say that the measure of angle E is equal to the big arc minus the small arc. And since this is one number, I gotta put parentheses around 360 minus x. And that's gonna be all over 2. And why do I put parentheses around 360 minus x? Well, let me go ahead and just tell you why. Well, with numbers, if I say 2 minus 7, well, that's going to be negative 5. If I say 2 minus 7, but I'm going to break 7 into two numbers, right? I'm going to think 5 plus 2 because 5 plus 2 is 7, right? I don't say 2 minus 5 plus 2. Because if I do that without the parentheses, well, 2 minus 5, that's negative 3, plus 2, that's negative 1. This just doesn't work. So, if I said 2 minus the quantity 5 plus 2, well, remember with order of operations, you have to deal with the stuff inside. So 2 minus 7, well, 2 minus 7, that's negative 5, okay? So the measure of angle E is equal to x minus the quantity 360 minus x, and then it's all over 2. So remember, if you have a negative here and it's in front of the parentheses, you gotta make sure that you distribute the negative. So the measure of angle E is equal to x minus 360 plus x all over 2. So then, what do I do here? Oh wait, the measure of angle E is already given, right? Well, the measure of angle E is 84, so I can go ahead and replace with 84. Okay, so now I have a working equation where I'm not dealing with two variables. Okay, so multiply both sides by 2. So I should get 168 equals x minus 360 plus x. Okay? So, now what? Let's go ahead and combine the like terms. I have x plus x, which is 2x. So where should I put that? I'm going to put that over here. So 168 is equal to 2x minus 360. And I'm going to add both sides by 360 here. I get 528 equals 2x. Therefore, x is equal to 264 degrees. And that's my answer. Alright, so we did 15 and 16. Let's take a look at number 17. Segment ML is tangent to circle C at point L. What is the measure arc LP? Okay, so the vertex is outside of the circle. So it's the angle, which is equal to the big arc, which we'll call measure arc LP, minus the small arc, 78 over 2. And since I'm looking for the measure arc LP, we have a fraction, 2 is the denominator, so I gotta multiply both sides by 2. So I have 72 equals the measure arc LP minus 78. And if I were to add both sides by 78, I get 150, which is the measure arc LP. And that's my answer. Number 18, we have two chords and they intersect at this point. The vertex is inside of the circle. So then what do I do? I gotta find X, which is right there. I'm given an angle. It's the top angle. That means I have to look at the top arc and the bottom arc, add them together, and divide by 2. Okay? So the angle, which is 128, is equal to the top arc plus the bottom arc all over 2. And then I gotta multiply both sides by 2 because we have a fraction and 2 is in the denominator, so we need to get rid of that. So 2 times 128 is 256, which is equal to 154 plus X. Subtract both sides by 154, I get 102, which is equal to our desired variable, what we are looking for. So X is equal to 102 degrees. Number 19, what is the equation of the circle with center 0, 5 and a radius of 9? Okay, so when you're dealing with the center, always write h, k, because h, k is going to be your center, non-negotiable. And then the radius of 9, that means that r is equal to 9. Remember, the equation of the circle, it has this equation. It's x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. So you're going to replace h and k with these numbers. So here's h, here's k. You're going to replace these two variables with these numbers. So it's x minus 0, quantity squared, plus y minus 5, the quantity squared, equals 9 squared. X minus 0, the quantity squared, is just going to be x squared, plus y minus 5, the quantity squared, is equal to 81. And that's your answer. Let's do number 21, and then I'm going to get back to number 20, because 20 is a long process. 21, write the equation of this circle. I'm given the center point, and here's my circle, so it should have a radius. So here's the radius, there's another radius, there's another radius, and there's another radius. So this circle, contains plenty of radii to work with. So again, the equation of the circle is x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. Let's identify the center point, which is 2, 1. So this is h, this is k, and then our radius, we're just going to go from the center to the circle. It's basically 1-2 units long, or if I go from here to here, it's 1-2 units long. Or you can just take the difference between these two numbers, these two x values to be exact. Okay, so the radius is indeed 2. So our center is 2, 1, and our radius is 2. So let's use this equation here. X minus 2, the quantity squared, plus y minus 1, the quantity squared, is equal to 2 squared. So your answer is this, okay? It's x minus 2, the quantity squared, plus y minus 1, the quantity squared, is equal to 4. Number 20, what is the equation of the circle that has a center at 1, -2 and passes through the point 3, -4? Graph below. Okay, so your center, well, first of all, let me write this again. The equation is x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. The center is 1, -2, so I'll write h, k here. And it passes through these random points. It passes through this random point, 3, -4. So I'm going to call that x, y, because it's a random point. Note that we don't have an r. No radius. Right? So if we're going to create our equation of the circle, we do need to have the radius. We have the center point, and then we have this point. So we're going to have to plug everything in and solve for the desired variable, r squared. So it's x minus 1, the quantity squared. Oh, sorry. Let me start over. We know, so if I'm plugging everything into this equation, well, x is 3. So I write 3 minus h, which is 1, the quantity squared, plus y is -4 minus k, so it's minus -2. Okay, so if it's -4 minus -2, we have a double negative. That means a negative times a negative is a positive. So I will just put a plus sign here. -4 plus 2, the quantity squared, equals r squared. 3 minus 1, the quantity squared, is 2 squared, plus -4 plus 2, the quantity squared, is -2 quantity squared, equals r squared. So then, move my work over here. 2 squared is 4, and then plus -2 the quantity squared. Well, -2 the quantity squared is basically saying -2 times -2. A negative times a negative is a positive, so that's going to be 4, which is equal to r squared. So 8 equals r squared, and y'all, if 8 is equal to r squared, and I'm plugging, or I'm sorry, if my equation has r squared, I'm basically going to take this and plug it in. Okay? But I also need to have my h and k. So let's go ahead and replace h and k. It's x minus h, which is 1, the quantity squared, plus y minus k, which is -2. But it's minus -2, so you gotta put a plus sign instead. So y plus 2, the quantity squared, is equal to your r squared, which is 8. Alright, so we're going to go ahead and graph the circle. So the center point is 1, -2, which is right here. And currently, we need to have the radius, right? But we know that r squared is equal to 8, and if I were to take the square root on both sides, well, let's go ahead and get my calculator out. The square root of 8 is 2.8. Approximately. So r is approximately 2.8. So that means I need to go up 2.8, which is about here. I need to go right 2.8. Oh, sorry, that's not right. It's 1, 2. Okay, that's right here. That's 2.8 because I got to go up 2.8 from that center point, and I need to go right 2.8 from that center point. So it should be right here. I need to go down 2.8, and I need to go left 2.8. And there you go. You have a circle. Alrighty, so that's number 20. Let's take a look at number 22. It says find the length of the arc ZY round to the nearest hundredths. Okay, so you're dealing with arc length, and I don't like this round to the nearest hundredth thing. I'm gonna say leave your answer exact. And in terms of pi. Okay? Alright, so let's go ahead and take a look at 22a. Your formula or your equation is L equals x over 360 times 2 pi r. So L is equal to the central angle, which is 75, over 360 times 2 pi, your radius, which is 4. So L equals 75 over 360 times 8 pi. This is where I'm going to get my calculator out. Input 75 divided by 360 into my calculator. And then I'm going to multiply that by 8. Math, enter, enter. So L equals 5/3 pi. (22b). This time I have a diameter. So I'm going to write L equals x over 360 times pi d. So L equals 130 divided by 360, because 130 is my central angle. And I'm looking for zy here. You multiply that by 10 pi. So getting the calculator out again, it's going to be 130 divided by 360, multiply that by 10, and then you're going to press math, enter, enter. Your answer is L equals 65 over 18 pi.